So max-min problems are going to be a bunch of word problems that we're going to use our quadratic functions and completing the square to find the solution. And the reason we can use that with a parabola is some parabolas open up, then their vertex is a minimum point. And some parabolas open down, then the vertex is a maximum point. So whenever a question says, can you find a maximum or a minimum, you're really concerned about something with the vertex. The easiest questions are ones like the first type. So the first type that you have are height problems. The reason these are the easiest questions is because the equation is given to you. It's really almost not like a word problem at all because you don't have to think, how am I going to get the equation? It's already given to us. So we have to solve by completing the square, part 2, right? This is not completing the square with equations, but our new completing the square where we change it to standard form. So first of all, you would factor out the -2, keep our +9, add our spaces. So when changing the standard form, we want this. We want our equation in standard form, which means the a value is factored out. So we start by factoring the a value out. And we only factored out of the first 2 because the 9 is going to be part of whatever q is. Now, as soon as we factor out that -2, we've got our hint. We know this needs to be something squared. It's going to be t, and because the -2 there, you know that it has to be a -1, which then allows us to fill in the spaces. If that's a -1 and you square it, there would have been a +1 there. That +1 gets hit by that -2, so by adding a +1 in that square, in that space, we've actually subtracted 2 on the right-hand side. So to compensate, we need to add 2. And as a result, this becomes +11. So once you have changed to standard form, you know your vertex. Okay? And your vertex will tell you information about maximums or minimums. Do you see that this one has a maximum because it's going down? So that 11 will be the maximum height. The 1 that's your, in this case, your time when you get the max. After 1 second, it's at a maximum of 11. So what is our units here? Max height, 11 meters. Okay? So that's what the question is asking for. Find the maximum height. So the maximum or minimum will always come from that y-coordinate of your vertex, and the x-coordinate will be whatever the x variable is representing when you get that maximum. Type 2, number problems. And with the number 4 and 6 there, that's saying that after you've done this in your book on page 323, you can circle questions 4 and 6. So I don't know if you want to write it above there or not. Unlike the height question, this one doesn't give you an equation. So we have to do the work to get the equation. Find 2 numbers that add up to 12 and whose product is a maximum. Okay? The nice thing about these questions is we can actually do a little bit of guessing and checking to see. Can anybody tell me 2 numbers that if you add them together, you get 12?
6 and 6.
6 and 6, okay? So that was our first one. 6 plus 6 equals 12, and 6 times 6 would be 36. Okay? What's another two numbers that add up to 12? 10 and 2. 10 plus 2 equals 12, but 10 times 2 equals 20. So far, 6 and 6 are winning, because we want the maximum product, right? Any other ones? 8 and 4. Can you see that 8 times 4 would give you 32? This one is still winning.
5 and 7.
5 and 7. 35 is closer, but 36 is still winning. Okay? What about, 9 and 3? Okay, that makes 27, so 6 and, we could go into decimals. Or are we convinced 6 and 6 is the best? Or there's decimals. What about 7.5 and 4.5? And now the mental math is like, oh. So how do we find out for sure? It seems, after a couple of guessing and checking, that 6 and 6 seems to be the best answer. Well, how do we create an equation in order to complete the square, change it to standard form? Well, you pick your two numbers. You write out your equation. Obviously, the product, which is what we want to find the maximum, is the first number times the second. Our first number, we don't know what it is, so we'll call it x. When you don't know something in math, usually like, well, I don't know, I'll call it x. Because it makes sense that the other one would be whatever's left from 12, 12 minus x. So this is enough for us so that we can write, this is the important thing here, we can write the two unknowns with only one variable. Because sometimes people will say, I'll make my first number x, what's your second number? Y. Well, that's great, you use two different letters, but that doesn't let you complete the square. So we always need to only use one variable. Now, in this situation, what would happen? First number is x, second number is 12 minus x. I think you have to write this down. You can expand it, and then I'll put the spaces in there in blue. I like this one because you still have to factor out the negative so that you get just an x squared. That'll change this to minus 12x. And even though there's no number, there's still a space before and a space after. And it does work out that the first number should be a 6. Our very first guess was right. Why do all this math? We're just lucky with our guesses. What a superpower. I'm like, new superpower. Whenever somebody asks you a question, you guess, and you always guess right. That's your superpower. You know how much you'd win on Jeopardy? Just guess. Like, got it right again? Wow. I'm gonna enjoy that superpower for a bit. So again, on our vertex, that's your max or min value. So the max product is 36. And the x value that gives you that is 6. So the other number, well, it's 12 minus 6, happens to be 6 as well. So a little bit harder than the first question because the equation wasn't given to you. Most of the questions you have will be ones where the equation isn't given to you. So you can circle questions 4 and 6. If you're circling questions, you can circle 5, 7, 8, and 9 already too, because we're going to do that next with our area problem. A man has 80 meters of fencing to build a coop for his chickens. He can use his barn as one side And I'm going to add into this question, there's a word missing. He's going to make his chicken coop in the shape of a rectangle. First of all, these questions are easier to do if you can draw a diagram, and the diagram, you're going to imagine you're up in the sky looking down. We're going to get a top view. Here is my barn. And I'm going to put fence here, fence there. And I want to make that as big as possible. Because you want your chickens to be able to move around. If you make, for example, a very bad chicken, let's do some examples. You've got 80 meters, right? You've got 80 meters of fencing. Here would be a very bad chicken coop for your chickens. You decide to only do 1 centimeter here, 1 centimeter here, and this ends up being 79.98 meters left. See, we have to have really skinny chickens for them to move along that fence. They'd all get stuck in there. Okay, that's really bad. Maybe we'll make it almost as bad, but we'll start with 1 meter here, 1 meter here, 78 meters left. Can you see that the area of this rectangle would be 78? Not a lot of room for those chickens to move around. They can basically just go straight lines back and forth along your barn. Okay? What's another possibility? Let's raise to 78. You have to come up with another possibility. We need the area to be more than 78. I think you'll probably be quite lucky in your guess. You will be more than 78. My first guess was really bad. But what could I make as dimensions? 25 here. Then this would also be 25, right? And then how much is left for this? 30. So then, let's see. Moment of truth. Is your answer bigger than 78? Yes. A little bit of it, drama there. 75, you thought it was low. 750. And we should use units here. This would be meters squared and meters squared. That's bigger. Is this the biggest one? Can someone think of numbers that would make it bigger? Or is that the biggest we get? Right? What do you think? So this will be 20 and 20 on both sides. And then that gives you more for this side, which would be 40, right, to add up to 80. 20 times 40. We've got a bigger one. Okay? But what completing the square is going to allow us to do is to find out for sure which one is bigger. Okay? So what did we do? We don't know what these actual lengths should be. So what do we do when we don't know something? We make something x. I'm going to make this side x, because how long is the other side across from it? X. And how did you figure out the number on the bottom? Yeah, you started with 80, and then you had to subtract both of the x's, right? So it makes sense that what is left is 80 minus 2x. And what I just did in this example is a great way for you to figure things out. Sometimes it's hard to go right to the variables. Play around with some numbers first. How long did it take you to figure out that the two opposite sides had to be the same? Not very long when you're doing it with regular numbers, right? Sometimes when this is taught directly, someone's like, well, how did you get this 80 minus 2x? But once you do it with regular numbers, you're like, well, I can do that mental math. I'm always subtracting what's left. Then these things make sense. Now, whatever you want to find the maximum up. So here we want the largest area. That's telling you what kind of equation you need to make. I need to make an area equation if I want to find a maximum area. And area is length times width, so this will be if you're 15, they'd be only 50. Does this make a parabola? Well, if I multiply it out, I've got a parabola. So I think about changing to standard form. That would mean I factor the negative 2 out of the x squared. If I factor the negative 2 out of the 80, there's no number, so there'll just be 2 spaces. And the 40 is our hint. So we know this has to be x minus 20. And minus 20 times minus 20, this will be plus 400. But what have we actually done? We minus 400, so we would have to, we minus 800. So to compensate, we have to add 800. Our vertex is 20, 800. This 800, that's your max area. Make sure we include our units. The 20 is the x. Well, what was the x? We have to go back to our diagram. The x was our width, right? So we can if x is 20, be 20 and 20, and what would be left on the other side? 40. Did someone guess the right one? Yes. Someone got the right one right to begin with. I could tell you the shortcut to figure out, like, if you give me any number for chicken fences on barns, say he went out and he got like, oh, he went into the bush and he found another 20 meters of fencing. I now know what rectangle he should build immediately with a shortcut.
What
I
rectangle
can't
should we
tell
build?
you, because if you find the shortcut, then you won't do the math anymore, and then I'll lose my job.
Don't tell us the shortcut, just tell us the number you found for 100 meters of fencing. 25.
Yeah, he figured out the shortcut. There we go. Don't say it out loud. Do you know what I have to do because people figure out the shortcut? I have to get the farmer to start being like, well, he has pink chickens and orange chickens, and they don't want to mix them together because nobody knows what color you get if you mix pink with orange. There's probably a name of a color, but I don't know it. I learned colors when my kids were little. They're watching kids shows. I learned colors I never knew existed. Like what happens when you mix yellow and green? You get chartreuse. Did you know that? I might be wrong now, but I think that's the color. Anyways, so we're gonna get some questions where the farmer puts an extra fence in there to make sure his pink chickens don't mix with the orange chickens, because that is a whole color problem that I am now unable to teach.